What is the biggest thing in the universe? In 1985, cosmologists believed that they had found the answer. A team led by John Huttrer at the Harvard-Smithsonian Center for Astrophysics had just completed a survey of thousands of galaxies in the direction of the constellation Coma Berenices. But as they looked through the results, they noticed something odd. Stretched across hundreds of millions of light years, a shape began to slowly appear. The shape of a person. A stickman. But the creature, with a long, slender torso, outstretched arms, and dancing legs, was no monster of ancient legend. It was one of our first glimpses of a supercluster. And it was not alone. Our observable universe turned out to be full of superclusters, roughly 10 million in total, each one containing tens of thousands, even hundreds of thousands of galaxies. Indeed, our own Milky Way is nestled inside one, known as Laniakea, on one of its outer limbs. And these superclusters are massive. At their smallest, they are several hundred million light-years long, composed of lacing, entwined branches and clumps of galaxies. The largest stretch across the heavens for up to 10 billion light-years, and their enormous volume is matched only by their mass. A typical supercluster can hold over 10 million billion suns worth of material. The nearest superclusters are named simply for the constellation we have to peer through to map them: the Coma, the Virgo, the Hydra Centaurus, the Parvo Indus. More distant ones are usually given simple catalogue designations, without fanfare or decoration, unless they break some record in size or distance. For example, the King Ghidorah supercluster, one of the most massive yet mapped, was discovered in 2022 by a team of Japanese scientists, who named it after a three-headed nemesis of Godzilla. But despite the monstrous size of these superclusters, their ability to encompass hundreds of thousands of galaxies at once, the way they bridge across light-years with strings of dazzling points, they are small. For there is a far larger, far more menacing class of entity inhabiting our cosmos. The true largest objects in the universe are nothing. These are no titans of ancient myth, or kaijus of modern cinema. They are the opposite, the shadow in the dark. For most of our universe is void. Nothingness. There are no lights to trace their structure, no gaseous filaments to highlight their nature. We can only detect them through their absence. The cosmic voids are the single largest objects in the universe. They define the superclusters, they define our existence. Everything we know and love, our home solar system, our galaxy, our supercluster, all exist suspended on the edge of the abyss. And they are the ultimate destiny of everything in the universe. The first universe simulations on computers were in the 1960s, N-body simulations able to simulate about 100 bodies at a time, a far cry from the recent Flamingo universe simulation with 300 billion elements. And certainly not powerful enough to run Opera, our sponsor today, the faster, safer and smarter choice than any of the default browsers out there. Opera has a great intuitive design, with things like Aria, a state-of-the-art generative AI created in collaboration with OpenAI. It is easily accessible and offers options to explain, explore, and translate any highlighted text on a page, very handy when looking through physics papers. It also has an integrated messaging systems for WhatsApp, Facebook Messenger, and more, a free inbuilt VPN and ad blocker, and most importantly for me, great little tab islands, for when I have gone down the rabbit hole on a scientific theory and want to have a lot of online books or documents open at once. It's an effective and secure browser option that those early universe simulators would have loved to get their hands on. So, click on the link in the description below to download Opera. It's free and you won't be disappointed. Thanks to Opera for supporting educational content on YouTube. Mapping the universe. The year was 1978, and astronomers Laird Thompson and Stephen Gregory had set themselves an exhausting task. Staying up all night for nearly a week at the Kitt Peak Observatory, located southeast of Tucson, Arizona, the pair of astronomers were painstakingly recording the positions of dozens of galaxies. After confirming the positions of these galaxies on the sky, they fed the light from their telescope into a simple tube that electronically amplified it. The forerunner of the modern-day digital camera, this technology allowed them to access exceptionally dim and distant galaxies, far greater than the reach they could normally get. They were peering further into the universe than any astronomer had before. Once amplified, they then passed the light from the galaxy into a spectrometer, and from there, Thomson and Gregory could measure the redshift of the galaxies, using that to work out the distance. There were no computers. No sophisticated algorithms. No automation. Thomson and Gregory were performing a survey of galaxies by manually recording their positions and distances. Of course, they were not the first to perform such a task. Astronomers had been carefully mapping galaxy positions for decades, but Thomson and Gregory had two tricks up their sleeves, two techniques previously unapplied to cosmology. One was their use of light amplification, but their second trick wasn't one of technology or theory or even deep insight. It was a plot. A method of displaying the positions of their newfound galaxies. The plot looked like a slice of pizza, putting the Earth at the pointy apex and broadening outwards as the distances from Earth grew. Though the idea may not seem important, it was revolutionary, because it allowed Thomson and Gregory to place the large scales of the universe in context, condensing the information into an easily digestible format. The plan for their survey was to map the galaxies in and around the Coma cluster, known for decades as a dense agglomeration of galaxies. They hoped to use their results to find differences between galaxies that were members of the cluster and those that were in that field, the random scattering of galaxies thought to be strewn about the universe. Instead, they found something else. A vast empty region, devoid of any galaxies. A patch millions of light-years wide that should have been full of galaxies, but wasn't. A flaw in the cosmos. Their new technique for plotting the positions of galaxies made it too obvious to ignore. A dense collection of black dots represent the Coma cluster, a smattering of dots here and there surrounding it, and in the middle, nothing. And so they gave a name to this blank space, a void. When Thomson and Gregory published their work, the astronomical community was skeptical, and sometimes outright hostile. We have already taken the measure of the heavens, they argued, and galaxies inhabited the whole of the cosmos. The pair of astronomers had clearly made a mistake. Perhaps they had some flaw in the design of their survey, or maybe their eyes were simply deceiving them. They wanted to see a void where there was none, and deeper surveys would reveal their mistakes, driven by their desire to make a dramatic discovery. No matter what, nature abhors a vacuum, and the void that they discovered should not, could not, would not exist. But that was in Europe and America. For mere months after Thomson and Gregory released their results, a trio of Estonian and Soviet astronomers and theorists published the results of their own survey in a different direction of the sky. Though their survey did not use the pizza-shaped diagram, they noted the existence of large holes in the distribution of galaxies. And on top of this, in contrast to the Western view of cosmology, Soviet-led scientists had been deliberately looking for such structures. In the West, the dominant paradigm of the large-scale structure of the universe simply could not admit the existence of voids. Cosmological theory held that the universe was homogeneous, meaning that it was, on average, roughly the same from place to place at large enough scales. The particular pattern of galaxies might be different here and there, but statistically everything was the same. Astronomers had known about the existence of clusters for some time, but those were just denser than average lumps in an otherwise random distribution of galaxies. For Americans and Europeans, voids simply didn't fit. ChatGPT. What is the biggest thing in the universe? In 1985, cosmologists believed that they had found the answer. A team led by John Hutter at the Harvard-Smithsonian Center for Astrophysics had just completed a survey of thousands of galaxies in the direction of the constellation Coma Berenices. But as they looked through the results, they noticed something odd. Stretched across hundreds of millions of light-years, a shape began to slowly appear. The shape of a person. A stickman. But the creature, with a long, slender torso, outstretched arms, and dancing legs, was no monster of ancient legend. It was one of our first glimpses of a supercluster. And it was not alone. Our observable universe turned out to be full of superclusters, roughly 10 million in total, each one containing tens of thousands, even hundreds of thousands of galaxies. Indeed, our own Milky Way is nestled inside one, known as Laniakea, on one of its outer limbs. And these superclusters are massive. At their smallest, they are several hundred million light-years long, composed of lacing, entwined branches and clumps of galaxies.